The forest did not burn, it lay combed flat for miles, as if a giant palm had pressed and lifted away. Over the bog, trees stood stripped and charred, pointing toward an empty sky. Welcome to Tunguska 1908, the morning the sky fell sideways. In a remote corner of Siberia, an unseen force knocked a forest down like wheat, yet left no crater. What follows is a careful retracing of the shock, the silence, and the questions. Siberia before the blast. In the early 20th century, central Siberia lay wrapped in remoteness, a vast stretch of coniferous taiga crisscrossed by blackwater rivers and soft expanses of peat. Much of this wilderness belonged to no one and everyone, its rhythms dictated by reindeer migrations, cold winds, and stars that filled the northern sky with eerie permanence. The Evenki people moved through it with inherited knowledge of weather and land. Russian traders and settlers clung to its margins hours or days from the nearest telegraph line. On the morning of June 30th, 1908, at about 7:14 a.m. local time, that quiet sky shifted. Witnesses in remote hamlets, including the eastern settlement of Vanavara, would later speak of a sudden flash, brilliant bluish-white, and a searing heat, as if the sun had leapt far too close. Doors slammed open from pressure, and windows vibrated in their frames. The glare lasted seconds, but its silence was unearthly. Telegraph reports trickled in, but Imperial Russia's bureaucracy was slow to act. The blast site lay far from railways, in a wilderness not yet charted. News traveled slowly across a continent, buried beneath other concerns of czarist politics. Weeks passed with no formal inquiry. Meanwhile, in cities as far away as London, residents glimpsed spectacularly bright twilights, nights that glowed as if touched by polar dawn. Papers mentioned it briefly. The connection to a boom in Siberia was a murmur heard and soon forgotten. Years would pass. The revolution would come, and with it, a more systematized approach to science. Soviet botanists and geophysicists, newly equipped and motivated to learn about their expansive country, began to revisit tales from the taiga. It was only then that the name Podkamenaya Tunguska, the stony Tunguska River, entered scientific discussions. Not because of what stood there, but because of what had vanished. Trees snapped, soil blackened, time scorched in place, and though no crater had ever been found, something undeniable had struck the region. The forest had spoken with force, and the sky, it seemed, had bent the rules. Kulik's long walk to an invisible crater. In 1927, nearly 2 decades after the sky shattered over the Siberian wilderness, mineralogist Leonid Kulik set out into the taiga to find answers. Believing he would uncover a crater left by a massive meteorite, Kulik organized an expedition into central Siberia. The journey to the suspected impact zone was as grueling as it was remote, weeks of travel across deep snow and thawing marshlands. Sleds creaked beneath them. Boats sloshed through slow rivers. Eventually, Kulik and his team continued on foot, swarmed by insects, and halted often by impassable bog. What Kulik found defied expectation. Rather than a singular scar or a gouge in the earth, there was instead a pattern. Trees, once towering larches, lay pressed flat in a radial sweep across an expanse of some 2,000 square kilometers. From a central point, the forest had been pushed outward in every direction, like petals blasted from the core of a flower. This strange and silent geometry became the defining mark of Tunguska. Closer to the epicenter, the scene grew even stranger. There, some trees still stood, but they were ghostly, upright trunks stripped clean of branches and bark, blackened and bare. They pointed toward the sky like scorched telegraph poles, silent witnesses to a vanished force. Burn marks were found on the sides of trees facing inward, while their leeward backs remained pale, unscathed. Kulik captured this devastation in a series of photographs, panoramic images of horizon upon horizon of leveled timber, the forest flattened in a fanned, almost delicate arc, but there was no crater, no fragments, no clear evidence of a falling rock. Kulik spoke with local hunters and traders in the region. They recounted the unforgettable morning nearly 20 years earlier, a flash so bright it seared the eyes, a wave of unbearable heat, and a shock that cracked windows as far as Vanavara over 60 kilometers away. In the scorched peat and tree resin, Kulik gathered samples, hoping to isolate metallic grains, perhaps traces of whatever had come down from the sky. But clues were elusive. The land offered no solid wreckage, no solid object at all. Instead, the forest bore a story told in orientation, trunks fanned outward, scorch marks frozen in time. It was as if the very atmosphere had detonated above them, then disappeared into thin air, leaving behind only this haunting symmetry as a mute testimony. According to archival accounts and geophysical surveys conducted later, including ring growth analysis in surviving trees, the energy released may have rivaled 10 to 15 megatons of TNT. Yet no impact basin. What Kulik uncovered was not a meteor pit, but a mystery drawn in lines and silence. What witnesses saw and felt. It was just past 7 in the morning on June 30th, 1908, when something cut through the sky above central Siberia. In the sparsely populated taiga near the stony Tunguska River, locals recalled seeing a bluish-white object streaking low across the heavens from the southeast. It moved too fast for a cloud, too fluid for stone, trailing an otherworldly tail of light. Some said it looked like the sun had torn loose from the sky. Eyewitnesses described a vertical column of intense brightness, followed by a flash that rivaled daylight. A heartbeat later came the sound, or rather two sounds. The first was sharp, explosive. The second rolled across the forest like distant thunder, shaking the ground and echoing off trees. Near the settlement of Vanavara, over 60 kilometers from ground zero, a man sitting outside his log house reportedly felt the air split open, then fold shut with a resounding blast that lifted him from his chair. The heat scorched his shirt, singed his hair, and left the pine needles around him curled and brittle. Across hundreds of kilometers, windows shattered. In villages far removed from the epicenter, church bells trembled on their own. Horses reared, children screamed. The magnitude of the concussion bewildered even those who never saw a flash. According to barographic records cited in later geophysical studies, the resulting pressure wave traveled around the planet, not once, but at least twice. A signature echoed in the pages of observatories from Siberia to London. For nights afterward, people across Europe noticed an eerie phenomenon. The skies glowed. Silvery, noctilucent clouds shimmered high above the horizon, unfamiliar and otherworldly. In London, street lamps stayed off, not by design, but because the sky itself was luminous. Scientists today believe these glowing veils were caused by microscopic ice particles suspended in the upper atmosphere, forming in the aftermath of an immense explosion. And yet no crater was ever found. The devastation, though immense, spread laterally. Trees flattened outward in a radial pattern over more than 2,000 square kilometers. But curiously, they did not burn entirely. The phenomenon suggested a blast that occurred in midair. A sudden thermal pulse, fierce but brief, left the forest scorched but unconsumed. This detail would become central to later theories. Whatever it was, the object never struck the ground. Its energy was released in the sky above, turning the air itself into fire and force. According to compiled field notes from Leonid Kulik's expeditions in the late 1920s, tree trunks blasted outward stood like charred matchsticks. Yet in the immediate ground zero zone, some even remained upright, stripped but not toppled. The pattern itself was a kind of signature, hinting at an airburst rather than an impact. In a place where silence once reigned, the sky had cracked open and poured out fire, pressure, and light, then vanished, leaving only questions and a scar across the forest that spoke louder than any words. Lines in the trees, clues in the air. In the decades following the blast, Soviet scientists returned again and again to the remote taiga, seeking forensic traces of the visitor from the sky. What they lacked in early technology, they made up for in persistence. Teams fanned out across the flattened zone, meticulously charting the orientations of fallen trees. Natural compasses that still pointed back to the airburst's epicenter like silent witnesses trapped in time. They measured irregular magnetic patterns in the soil and marshland. Peat cores were extracted from bogs long undisturbed, revealing hidden microlayers, minute spherules laced with nickel and iron, and silicate droplets glazed by intense heat. Their faint abundance hinted at a meteoritic origin, though nothing approaching a solid meteorite was ever found. These particles, though sparse, were unlike any that usually deposit from atmospheric dust or volcanoes. Tree ring data, laboriously collected from across the blast region, told another story. In the years after 1908, conifers leapt in growth. Without the thick forest canopy, sunlight poured onto soil once shaded. Scientists noted that nitrogen compounds, likely rained down during the event's plasma-rich shockwave, had acted as fertilizer. A subtle fingerprint of atmospheric chemistry etched in wood. Energy reconstructions, built from infrasound records felt half a world away, and seismic reverberations that unsettled Earth's crust suggested a detonation several kilometers above the surface. Estimates range from 3 to 15 megatons, a force that dwarfed mankind's weapons of the era, yet left nothing behind but scorched earth and charred trees. Eyewitness accounts waxed strange but proved useful. Villagers described a blinding fire column and thunder that rolled for minutes. Their locations, mapped against the direction of tree fall and damage, helped triangulate a trajectory low in the sky. The approach, computer simulations later showed, must have been shallow, something like a stone skipping across water. Bolide models suggested a fast-moving object entering from the east or southeast, scattering its energy sideways in a broad lateral explosion. This could explain the oddly symmetric butterfly shape of the devastated forest. One suggestion lingered into the late century, that nearby Lake Checo, a quiet oval splash of dark water, might be the long-lost crater. Yet sediment cores told a different tale, with layers dating back before 1908. Topographic maps from the late 19th century showed similar features, casting doubt on the impact theory. By the end of the 20th century, the case file was thick with data, trajectory angles, chemical analyses, and tree fall diagrams, pencil sketched with unstinting care. A picture had formed of something fast, hot, and celestial disintegrating in the sky. But the core mystery remained untouched. No fragment, no fused mass, no remnant of the intruder had ever been found. Just lingering signals, chemical, biological, and geometric, etched in the trees and air. Ice, stone, and stranger ideas. For over a century, two dominant theories have stood at the heart of the Tunguska mystery. The first pictures a cold cosmic intruder, a fragile fragment of a comet made mostly of ice, streaking through Earth's atmosphere at incredible speed. According to this view, the fragment disintegrated as it descended, never striking the ground. Instead, it vaporized in the upper atmosphere, unleashing an immense burst of energy that flattened over 2,000 square kilometers of forest. That same vapor may have lingered in the upper skies, glowing at twilight as the rare and haunting noctilucent clouds reported across Europe in the days that followed. These shimmering veils, high above the horizon, suggested strange things had entered the stratosphere. The second explanation draws from harder material. It proposes a stony asteroid, a compact, denser object that tore apart under the crushing forces of atmospheric entry. As it shattered, it converted its incredible kinetic energy into a blast wave midair. This airburst, erupting kilometers above ground, matched the radial flattening of trees and the absence of an impact crater. The asteroid, likely composed of carbonaceous rock, could account for the faint traces of exotic elements found at the site. If fragments survived, they may have been scattered too widely or had vaporized under the intense heat and pressure. Out on the fringes of speculation lie more exotic scenarios. Some have proposed a massive subterranean release of natural gas, ignited in a freak atmospheric event. Others have turned to ideas from the edges of physics, an encounter with antimatter, or even the near-miss passage of a micro-black hole. Though intriguing, these ideas struggle under the weight of evidence. They often lack independent support, and crucially, they cannot fully explain the well-documented circular blast pattern, tree fall direction, or eyewitness reports. Modern studies, especially those informed by the 2013 Chelyabinsk event in another part of Russia, have lent clearer perspective. Although far smaller, Chelyabinsk provided real-time footage and precise scientific data on how a shallow atmospheric entry can produce a powerful shockwave. The Tunguska blast appears to scale up this principle: a low-angle approach, a rapid fragmentation in the air, and a shockwave that spreads laterally, racing across the taiga. In this light, even the vivid accounts of a pillar of fire rising into the sky may not be mythical. They could be the visual signature of streaking plasma and burning debris, a fireball blossoming in the air, momentarily towering above the Siberian wilderness, then gone without a trace. Regrowth and risk. In the years that followed the Tunguska explosion, time and nature began their slow collaboration. The forests, once flattened in a radial sprawl from that mysterious 1908 blast, started to regrow. Rings of life emerged from the ruins. Young larch and birch thrived in the cleared corridors, rising in neat progression where older forests had been swept away. Yet at the center, the death remained visible. Blackened standing trunks, snapped and stripped, still decayed where they stood, silent reminders of force unmarred by fire. By the 1950s, aerial surveys traced the lingering geometry. Though softened by resurgence, the blast's ghost pattern was still etched into the land, a radial imprint, subtle in tone, unnervingly perfect in structure. It was a wound the forest wore openly. The site evolved into a kind of open-air archive. Field schools and geology camps made pilgrimages to the blast zone. Students stepped into muskeg fields dense with peat, a spongy earth that held ash traces, unusual metal spherules, and even preserved ancient pollen disrupted by the event. In this environment, learning came at the sensory level, underfoot, in the hum of mosquitoes, in the distant rush of birch leaves folding into one another. For the Evenki people who lived along the Tunguska River, the blast was never just science. It became a story anchored to the land, a caution carried across generations. Hills, rivers, and silhouettes near the impact point gained meaning through oral memory and seasonal signs. The explosion had not erased their presence, it had rearranged the spiritual geography. Far from Siberia, Tunguska became more than anecdote. Scientists began to see it in new light, not just a curiosity, but a warning. In the late 20th century, astronomers and planetary scientists linked Tunguska to the broader risk map, the developing science of planetary defense. The idea that Earth could be struck without warning by a cosmic visitor shaped conversations around bolide modeling, atmospheric entry mechanics, and international cooperation on impact monitoring. One blast in the taiga had reframed an urgent global question. What do we do with events that are rare, but not impossible? How do we prepare for energy released in seconds, the kind that leaves no crater but reorders the landscape? And perhaps most humbling, how do we interpret aftermath as evidence when the force itself leaves no clear witness? Tunguska became a textbook not for what we understood, but for how we seek understanding. A force that came from the sky and left questions rooted in the soil. Patterns without a piece. The Tunguska event resists definition, not because it defies science, but because it leaves behind only the echo of an answer. No single photograph captures it. No crater centers its chaos. What remains is a pattern, a vast scarring of the Siberian taiga, millions of trees felled in a radial design stretching over 2,000 square kilometers. It is a fingerprint made not in dust or dirt, but in pressure and fire. This was not an impact, but an impression, an object never fully seen and never recovered, disintegrated in the sky with such force that it left only absence in its wake. In that void, scientists have built models and run simulations. Atmospheric physicists calculate the energy yield, compare it to atomic detonations, and trace the blast radius into tree ring anomalies. From the scars on trees, they estimate the altitude of detonation, somewhere between 5 and 10 kilometers above the forest. According to Soviet geophysical studies, the energy released may have been equivalent to 15 megatons of TNT. Yet still, there is a moment that resists equations, when sunrise shattered into a white-hot column and the forest sank beneath a wind without sound. We try to frame this event with language, airburst, bolide, cometary, fragment, but the terms tumble short of resolving the enigma. Witness testimony, like that recorded decades later, speaks of a fiery body and a pulse in the sky so bright it casts shadows at daybreak. And this is perhaps where the deepest mystery resides. Not in what was destroyed, but in how little we truly saw. Most of Earth's sky, then as now, passes overhead without witness. The events that do occur might not leave a crater, a solid proof of their passage, but only subtle changes. Tree bark scorched, soil compacted, rings stunted. Science reads these traces like pages from a scorched book. Each pattern hints at its missing linchpin. Where certainty stops, wonder persists. It is this blend of data points and deep mystery that keeps the Tunguska event alight in the collective memory. Not as a solved case, but as an open question inscribed on the landscape. One we read again and again in search of a piece that may no longer exist. This has been Tunguska, 1908, the morning the sky fell sideways, a careful walk through a blast that left no crater and a century of questions. Thank you for traveling with Nightmare Nook. Subscribe for more investigations where the evidence is quiet and the echoes last.